Hello, my name is John Sweetman, and this is my presentation on the moons of the outer solar system. We will start with the 4 Galilean moons of Jupiter. These are the 4 largest of the Jovian planet, and they get their name Galilean moons because they were first observed by Galileo in 1610. These moons are from largest to biggest, or from biggest to smallest: Ganymede, Callisto, Io, and Europa. First off, and largest of the 4 moons at 5,270 kilometers in diameter, is Ganymede. The moon has the biggest mass of the Galilean moons, which is 2 times that of Earth's moon. Its orbit is the 3rd furthest from Jupiter of the 4 Galilean moons and consists of just over 7 days. Ganymede consists of an icy outer crust, an ocean of water beneath the crust, then a rocky mantle, and finally an iron sulfide core. The Galileo spacecraft, launched in 1989, was designed to observe and research the Galilean moons, and flew within 1,000 kilometers of Ganymede. The spacecraft made the discovery that Ganymede had its own magnetosphere. Jupiter's second largest moon, Callisto, is comparable in size to the planet Mercury at roughly 4,800 kilometers in diameter. It has the mass of 1.5 Earth moons and has the furthest orbit from Jupiter, lasting 16.7 days in length. Callisto consists of an ice-rich lithosphere, and underneath that, an unconfirmed ocean at an estimated 150 kilometers deep. Callisto has a large rocky and icy interior that makes up most of the planet's mass. It is the only Galilean moon far enough away from Jupiter's magnetosphere where harmful radiation does not interfere with the planet. It is also darker than the other moons. Io, perhaps the most interesting of the Galilean moons, is the closest to Jupiter and has an orbital period of 2 Earth days. Io is the 3rd smallest in size, at 3,640 kilometers in diameter, and has a mass of 1.22 Earth-Moon masses. Io experiences extreme radiation from Jupiter's magnetic field and tidal forces from the planet and neighboring moons. These tidal forces cause intense heating inside of the moon, which is thought to cause the numerous volcanoes that can be found on the moon. Due to the extreme volcanism and radiation, it is unlikely any life is present on the moon. Io and Jupiter create an electric current of 3 million amperes due to their proximity. Because Io is located so close to Jupiter, Jupiter's magnetosphere rips apart at Io, causing particles to be shaved off and launched into space. These particles are ionized outside of the moon and create what is known as a plasma torus around near the orbit of Io. Any ions that escape this plasma torus help to inflate the magnetosphere of Jupiter further. Io has a thin lithosphere, which magma spews out of in the form of volcanic eruptions. Due to Io's complex nature and its proximity to Jupiter, it is uncertain what the exact interior of the moon looks like. The mantle is thought to be in one of 4 states. The first state being that a deep mantle heating could be occurring, melting rock from the deep mantle and having it be pushed out through the astronosphere and eventually through the lithosphere and erupting in the form of volcanoes. The second state is that the melting only occurs in the astronosphere and not the deep mantle, and this molten magma eventually bursts out of the lithosphere as well. Third, a magma ocean could be present underneath the lithosphere, detaching it from the rest of the mantle, causing it to be floating. This magma ocean would be the primary source of magma for the volcanic eruptions. Fourth, a partially molten ocean of magma could be in place, so that the lithosphere is still connected to the mantle, but there is still magma present in the asthenosphere, just underneath the lithosphere. Lastly, the core is made up of solid iron/iron sulfide. Moving on to the last of the Galilean moons is Europa. The moon is smallest in size at 3,130 kilometers in diameter, and the smallest in mass at about 0.65 Earth-Moon masses. It is located second closest to Jupiter of the four, and due to its icy surface, it is brighter than Earth's moon and reflects more sunlight. It is also the most likely Galilean moon to harbor life. A water ocean is likely present beneath the icy surface. Evidence of this comes from a magnetic signature coming from the moon that does not come from its core, cracks in the crust that could be caused by the tides, and a tidal flexing which generates heat, and this heat would be the reason why the ocean underneath the crust is not frozen solid. The layers of Europa consist of an icy crust, a liquid water ocean, a rocky mantle, and yet another iron/iron sulfide core. Before moving on to Saturn's moons, the Cassini-Huygens spacecraft helped make important discoveries about some of Saturn's biggest satellites. Some of the tools on the spacecraft include a magnometer, infrared spectrometer, UV imaging spectrograph, ion and neutral mass spectrometer, microwave sensing radar, and a visible and infrared mapping spectrometer. Of the moon Titan, the Cassini spacecraft discovered lakes and seas of liquid methane on the surface. It found evidence of an internal ocean, likely made up of water and ammonia, and discovered seasons lasting about 7.5 Earth years, and visible dunes made up of hydrocarbons along the moon's equatorial regions were also found and pictured on the slide. These dunes are significantly larger than ones found on Earth. On another one of Saturn's moons, Enceladus, the Cassini spacecraft discovered geysers spewing water vapor and ice out of the southern pole, seen pictured on the slide. This is likely due to an underground ocean, and evidence of this includes the geysers, as well as lack of craters near the South Pole, tectonic patterns, and the possibility of heating through tidal mechanisms similar to the one found on Io. With this information in mind, we will move on to Titan in more depth. Titan's atmosphere consists of 95% nitrogen and 5% methane. It is not sure the reason of where the methane comes from. The atmosphere of Titan extends 10 times higher than Earth's, and Titan experiences storms like Earth's, however the rain is in the form of methane. The reason that Titan's atmosphere extends further than Earth's is due to its mass being significantly less than Earth's, allowing less gravity to be pushed down onto the atmosphere, bringing it closer to the moon. This liquid methane from the rain pools in streams, lakes, and ponds. And in the atmosphere of Titan, heavier carbon-rich particles fall to the surface, creating Earth-like sand dunes, similar to snow. Titan is the only moon with a thick atmosphere similar to Earth's. The sun's UV light and accelerated particles from Saturn split up and recycle molecules in the atmosphere, which creates the yellow hue of the moon. Telescopes that view wavelengths outside of the visible spectrum can peer through the yellow hue of Titan. The UV light from the sun decomposes the methane in the atmosphere, which means that the source must come from somewhere on or inside the moon. The next of Saturn's moons is Enceladus. A much smaller moon of Saturn, but still one of the major ones. Plumes spraying water near the southern pole were discovered, which is evidence of a subsurface ocean. These vents could be the cause of hydrothermal vents, like those found on Earth. Traces of methane were also found in the plumes, which could act as an energy source if any life were to be found on the moon, similar to how life started on Earth. Moving away from Saturn and onto the next planet in the solar system, Uranus, we find the moon Oberon. It is the second largest moon of Uranus and is made up of ice and rock. It is heavily cratered and is the outmost of the 5 major moons of Uranus. It is believed to be geologically inactive. Quickly moving on to Neptune, we discover Triton. Triton was only discovered 17 days after Neptune was, and is the largest of its moons. It is unique because it is the only moon in the solar system that rotates opposite its host planet's rotation. This is thought to be due to the moon not originating as a moon of Neptune, but from another planet or from not a planet at all. It is so cold on Triton that nitrogen exists as a solid, and the moon also has been found to have active geysers, making it geologically active. These are my references, and that concludes my presentation. Thank you.